This lesson goes along with section 14.1 on graphing sine, cosine, and tangent functions. What you guys have done before is you have used a unit circle, and every point on the unit circle has corresponded to a cosine and a sine value, and then you've divided to find tangent. What we're going to do for this section is we're going to take, for example, all of the sine values, and we're going to plot them on one curve. That's called a sine function, and it actually makes a periodic wave there. And we call it periodic because it repeats itself. And that's a property that we'll be playing around with. So here's the information for a sine function. A sine function is in the form of, you guys can see that, y equals a sine of bx. A represents my amplitude. The amplitude is half the difference between the maximum and the minimum of my function. So for example, if this curve represents my sine function, and this is a pretty general curve for that, and you'll see what I mean in just a minute, the amplitude is the distance between this maximum and the halfway point. That's the amplitude. And I can read that right off of the function by looking for that number that's in front of sine. Both a and b, remember, if you're given some variables, that just holds the place for a different number. So to find the amplitude, I'm going to take the absolute value of that a value in front there. Okay? I also have a period on my sine function. The period is the horizontal length of each cycle. So the sine function is periodic. That means that it doesn't just stop here. It actually keeps going and so on and so forth. But what we want to focus on is what one period of that cycle is. And the way we find that is we take 2 pi and divide by that b value, the absolute value of that b value. So for my function, I start at the origin, I go through once, I'm going to cross the x-axis once, and I end up back at the x-axis again. That's one cycle, because now I'm going to start over and get another maximum. So this length is this is the period. Other properties of a sine function include you're going to have a maximum and a minimum. And right now, remember, we're just focusing on a sine function. And you're going to have some x-intercepts, 3 x-intercepts. Okay, and the next slide tells you how to find those values, and then we'll do an example. To find the first x-intercept, what you're going to do is you're going to take, remember, x-intercepts are coordinate points. Okay, so this would be the coordinate point of half of the period, and then 0. And the second x-intercept, so the second place where you cross the x-axis, is the actual period and 0. So for problems, you guys would have to identify the x-intercepts. This is how you find those. A sine function always starts at 0, 0. Okay, so technically you have 3 different intercepts. The first one is just going to be 0, 0. For now, before we start learning about translations. Okay, to find the maximum and the minimum values of a sine function, you're going to take 1/4 of your period. That's the x-coordinate of your maximum. And then the y-coordinate would be your amplitude. Okay? To find the minimum, we take 3/4 of the period, and then it's the negative amplitude value. So get these in your notes, and they're really going to make sense once we do this example. Okay, so there's a lot going on this slide. What this is showing the parent function of a sine function. So if you guys see here, we have our sine function, a sine of bx. What we're graphing is we're graphing the parent function. We're graphing y equals sine of x. Okay, notice there's nothing in for a, nothing in for b. What does that mean? That means we have that hidden 1. So my a is 1 and my b is 1. Okay, so now let's think about our period here first. To find the period, remember, we're going to take 2 pi and we're going to divide it by the absolute value of what's in front of x, and we just have 1. So right now our period is 2 pi. And you guys can see that that's correct. We start at 0, and one cycle of that graph goes from 0 to 2 pi. The amplitude is what's in front of the actual sine. There's a 1 in front of sine, even if you don't see it. And you guys can see our function goes up to 1 and down to -1. So our amplitude is 1. And again, these are all the properties of the parent function. Okay, so these would stay the same. Remember, for the zeros, to find those zeros, the first point is 0, 0. That's my starting point. My second point is half of the period. My period is 2 pi. Half of 2 pi is just pi. So at pi 0, I have another intercept. My last intercept, or 0, is the actual period, and then 0. The maximum of my function is going to be half, or a fourth, of this distance here. Okay, so a fourth of your period. So I'm going to take 2 pi, divide that by 4, we get pi over 2. And then your amplitude value, which is 1. Okay? To find the minimum, we can think of it a few different ways. You can take 3/4 times the period, or we can kind of look on the graph here and see what we're doing. Okay? Once we get those intercepts in, once we know then we can kind of draw in our curve. Sine curves are kind of cool because they follow the same type of pattern. So we can just look halfway between the origin and your second intercept there. Halfway is going to be your maximum. The other way, halfway between your second and your third intercepts, that's going to be your minimum. Okay, so we can see that's 3 pi over 2. And then the negative amplitude value of -1. These values are standard for a parent function. So these will stay the same. Now we're going to do an example where we actually go through and calculate the different values so you guys can see it. Make sure you get this in your notes because this is a very good starting point for any graph.